Okay, so I've got a thin lens, right? Let's do a double convex just because it's the easier one to deal with right now. Always sketch out a picture of what's going on. Always sketch out a picture, do a ray diagram. Okay, it doesn't have to be perfectly to scale. Just to get the idea of what's happening here. Okay, so I'm calling this F2, F1 instead of F prime. You have the focal length F is equal to 35 centimeters. 35 centimeters. Image distance, U. Let's do an easier one. Let's have an outside focal length right now. Let's make it 45 centimeters. So that means the image that we're talking about, the person here, is something like this, right? Right here. Let's give it a height, H. Yeah, excuse me, object. Thank you, Luke. Object U distance, not image distance. Let's give our object the height. Okay, let's give them a height. Let's say, let's use it in meters right now. It's a person. Let's say about 1.5 meters. That's relatively normal. Here for me, there's 1 meter, right? I'm a little over 1.5. I'm about 1.8 approximately meters, right? So, 1.5, that's somewhere average, right? 1.5 meters. And my question to you is, what is the image distance? Right? What is the image distance? What is the image height? And what is the magnification? Right? I want all three of those, for example, in this problem. Now, before you solve this mathematically, sketch out the ray diagram. You can already know what in general to expect. So a ray that comes out parallel refracts through the focal point. A ray that goes through the focal point refracts parallel. And a ray that goes through the center keeps on going. Now, I'm sketching this out really fast because I want to get to the math, because I know the math is going to give me the correct answers. All I'm looking for here is to get what in general do I expect, which these rays are intersecting somewhere over here, so I'm getting a person like this, right? I expect this to be an inverted image, right? That means H prime should come out to be negative, right? H prime should come out to be negative. I'm expecting it to be real, which means V should come out to be positive, right? Magnification. From this perspective, it looks like it should be bigger, so I expect it to come out greater than 1, right? And since it's upside down, it should be negative. So I've got the general idea of what I want. Now, do not overthink this. Do not overthink this. Just because it came out to be greater than 1 in my picture, right? And the magnification is greater than 1. Don't freak out if the math gives us a magnification of like 1.2, and you're looking at your picture going, oh gosh, it should be like 2 point something. Don't freak out about that. Don't freak out about that. Your picture shows that it should be bigger. Just expect it to be bigger, right? And we'll deal with that later. Now, math. I'm given these things. First thing, the easiest thing to calculate would be, for us right now, the image distance, V. So using the thin lens equation, 1 over F equals 1 over U plus 1 over V. I don't remember in what I had you take your notes if I flip-flop U and V. It doesn't matter, right? 1 over 2 plus 1 over 3 is the same thing as 1 over 3 plus 1 over 2. Who cares? Right? So this focal length is positive. It is a convex lens. So this is 1 over, and I can use the centimeters here. I can use the centimeters right now because they cancel out. The units cancel out here. So 1 over 35 plus 1 over 45 equals 1 over 45 plus 1 over V. Okay, 1 over 35 plus 1 over 45 plus 1 over V. Next step in the algebra here, that would be 1 over 35 minus 1 over 45 equals 1 over V. And this is very similar to resistors in parallel. Do not forget to take the inverse at the very end. My recommendation to you right now is punch in your calculator 1 over 35 minus 1 over 45 and just get a nice little decimal number. So what is that decimal number? 0.006. Give me another number after that. 006.
3.
3. That works. Equals 1 over V. This is just like with parallel resistors where people make mistakes. They say that's what the V is, which that doesn't even make sense, right? That small, you have to take the inverse of that, right? Take the inverse of both sides to get V equals what? 157.5. And that's in centimeters, right? Because that's what I've put in. Now, let's get that correct sig figs for now. I've got 2 sig figs. So the correct answer for V would be 160 centimeters equals V. But I'm going to use the more accurate one to plug into other guys. The answer I would report, though, would be 160. Okay, so if I were doing an IB exam, I would write down 160 centimeters, circle that, and then if I had to carry that number over to the next question, I'd use 157.5. Okay? Now, this is so far so good. This is what I expect. It is a positive number for the image distance. That's what I said we wanted because of our picture, right? So our picture and our math is currently our picture is currently confirming our math. So far we're good. Now, image height, right? I can't get image height just yet. The way you get image height is from magnification. Magnification equals h prime divided by h. I don't know the magnification, right? All I know is h. So instead, let's use the equation also. Magnification equals negative v divided by q. I know these things right now. This gets me one of the other guys. Magnification equals negative 157.5 divided by that object distance, 45 centimeters. What's that magnification come out to be? Negative what? Negative 3 point what? Negative 3.5. No units. No units. It's kind of like the coefficient of friction. Units. Units. Okay. It's a. All magnification is a ratio, right? Ratio of the heights, ratio of the distances. Since it's a ratio, ratios don't have units, and units cancel out. It's just kind of, it's a multiplier, if you will, right? So this is what I expected also. Negative meaning it's inverted, right? It's upside down. Our picture confirms that. And it's greater than 1. 3.5 is greater than 1. It's bigger. And I expected that from my picture too. All right, so far so good. Now I can come back over here to this other magnification. I got negative 3.5 equals h prime divided by h. And the height that I gave you was 1.5 meters. Now, here's the great part about this also. Magnification is just a multiplier. It's unitless. I don't have to convert that 1.5 down to centimeters because that's what I was using in the rest of the problem, right? If you look at that equation of itself, I've got magnification unitless, so I plug in meters. What do I expect to get out? Meters. Good. So what does h prime come out to be? Negative, I'm sorry? Negative 5.2. Should come out bigger. Negative 5.25 meters. I need to report that to sig figs. So h prime equals negative 5.3 meters. Good.